Hi viewers, today our topic is core of embedded system. The core of embedded system falls into any one of these categories. First one, general purpose and domain specifications. These general purpose and domain specification processors are microprocessor, microcontroller and digital signal processor. And the second one is application specific integrated circuits, ASIC circuits, programmable logic devices, commercial off-shell components. These are the core systems of the embedded systems. First one, general purpose and domain specification processors. In every embedded system, microprocessor, microcontroller, digital signal processors, these three are the main heart of the embedded systems to design the various to perform the various tasks or to design the various or multi devices. Without microprocessor, controller and DSP processors, we cannot design the embedded system devices. First one, microprocessor. Microprocessor is a heart of the computer system. It is just a processor, memory, input output components have to be connected externally. Memory and input output has to be connected externally, so the circuit becomes large. In microprocessor, we cannot be used in compact systems because it is an inefficient. The cost of these microprocessor is increases. Most of the microprocessors do not have power saving features, and the microprocessor have less number of registers, hence more operations are based on the memory. Since in microprocessor the input output components are external, each instruction will need external operations, hence it is relative. Microprocessors are designed to perform an unspecific task like developing software, games, website, photo editing, creating documents, etc. The relationship between the input and output for microprocessor is not defined. In microprocessors need high amount of resources like RAM, ROM, input output ports. The clock speed of this microprocessor is quite high as compared to the microcontroller. The applications of these microprocessors are used in calculators, accounting systems, traffic lights, computers, TV, military applications, computers, and etc. Next, second one, microcontroller. Microcontrollers are designed to perform specific tasks. However, the input and output, the output depends upon the present input. Here in microcontroller, the processing of microcontroller need to done, output is defined. The applications of microcontroller are very specific. They need small resources like RAM, ROM, input output ports, etc. And in embedded single chip microprocessors also used. These microcontrollers are used in compact systems, hence it is an efficient technique. The cost of this microcontroller is low compared to the microprocessor. In microcontroller, the input output are present in internally, so the circuit designing is small. Most of the microcontrollers have power saving modes like idle mode, power saving mode. This help to reduce the components or internally. Most of the microcontroller operations are internal instructions, hence speed is fast. The microcontroller have more number of registers, hence the program are easier to write. The applications of these microcontrollers are mostly used in mobile phones, automobiles, DVD players, washing machines, cameras, keyboards, MP3 players, and so on, etc. Next one, digital signal processor. This digital signal processor is an powerful and special purpose processor. In this digital signal processor, we have to use 8-bit, 16-bit, 8, 16, 32-bit microprocessors design. Here, the digital signal processors are 2 to 3 times faster than the general purpose microprocessors in signal processing applications. Generally, the digital signal processors have 3 key units. First one, program memory. This program memory is used for storing the program required by the DSP to process the data. Second one, data memory. This data memory is used for storing temporary variables, information, and data signal to be processor. Third one, input output units. It acts as an interface between outside world and DSP processors, and these input output units are mainly used for capturing the signals, processing the signals, and delivering the signals through input and output units. The applications of these DSP processors are mainly used in audio video signal processing and telecommunications and multimedia applications. In the real-time applications of these DSP processors are mainly used for large amount of real-time calculations like convolution, discrete Fourier transform, linear convolution, and circular convolution. These are the applications of the DSP processors. Next one, PLDs, programmable logic devices. The PLD is an electronic component. It is mainly used to build digital circuits which are reconfigurable. In digital circuits, logic gates has fixed functions, but PLDs does not have a defined function at the time of manufacture. PLDs offer customers wide range of logic capacity, speed, voltage characteristics. These PLDs to perform any number of functions at any time. These PLDs are divided into two types: complex programmable logic device CPLD and field programmable gate arrays FPGAs. CPLD offers small amount of logics up to 1000 gates. Field programmable gate arrays, it offers highest amount of performance as logic density. The advantages of these PLDs offer customer much more flexibility during design cycle. The PLDs do not require long lead times for prototypes or production parts of these PLDs. The PLDs can be reprogrammed. Next one is commercial off-shell components, COTS components, may be developed around a general purpose or domain specific processors or ASICs or PLDs. The commercial off-shell components, the major advantage of using the COTS components are readily available in the market or cheap, and developers cut down head development to great extent. The major drawback of the COTS components in embedded design is manufacturer of the component may withdraw or the product discontinue or the production of COTS at any time. Changing technology occurs. Next when application specific integrated circuits. This ASCS is an microchip designed to perform a specific and unique applications. Because of using single chip of integrated, it integrates several functions, thereby reduces the system development and cost. The integrated circuits is a single chip consumes a very small area in total system. It helps in design of smaller systems with high capabilities or functionalities. Most of these ASCs are which having some trade names products. It is referred as application specific standard products. The developers of these chips may not be interested for revealing the internal details of these ASICs. The it consumes low power and low, low size, low cost. The design of these circuits are very simple in embedded systems. This is the core of the embedded system, most important topic in embedded systems. Thank you for watching. Please like and subscribe my channel.